The instructions are the same since it's what it's been, so don't worry about that information. We're going to be keep using the same rules. Okay, so on this group, I have divided these notes into two different parts. Let me show you. Simplify the radical expression where n is an odd positive integer. Okay, n is an odd positive integer. Okay, I guess you don't really need to know the positive part, but n is odd. Okay, remember when n is odd, that's when we don't have to think about absolute value signs. Then, when we get down here, I remind you of the rules. But in this case, n is even. So if n is even, that's when we have to worry about absolute value signs. Okay? So let's go back up here where we don't have to think about it and just do the work. So if I know that this n goes on top and this n goes on bottom, what's n over n? 1. So it's just x to the 1 or just x. X to the 3n over n. If you have an n on top and an n on bottom, they cancel out. And we're left with x to the 3rd. So on this one, I'm going to get technical on this first one like this, but maybe I won't have to afterwards. If I have, actually, let me erase this and do it where I actually have room to write. Excuse me. Right here. So we have x to the n plus 1 over n. And that can be separated to n over n plus 1 over n. And that means n over n is 1 plus 1 over n. I know it's like, what in the world are you talking about? But here we go. If we have this 1, that one comes to the outside. And since we have this left over, it stays on the inside. Okay, so that would be the answer for that one whenever n is odd. On this one, it's negative x to the 3n over n. N's cancel out, which we're left with negative x to the 3rd. Because if you have an odd amount of negatives, your answer is going to be negative. This is the same exact problem as this one, except because your n is odd, our answer is going to be negative. X to the 2n over n, y to the 3n over n, n's cancel, x squared, y to the 3rd. They could all be that way, right? Okay, so on this, x minus 9, n over n plus 1 over n over n is 1. So x minus 9 comes to the outside, but we're left with leftovers. We have 1 left over, so it stays on the inside also. negative x plus 1, 3n over n plus 1 over n. N's cancels, which leaves you with 3. So we have negative x plus 1 to the third on the outside. That's a 3. And then we have just x plus 1 left on the inside. Okay. Even roots. Even roots is going to have to worry about absolute value signs. X to the 5n over n, which makes it x to the 5. Since this is even and this is odd, we put it in absolute value signs. X to the 4n over n, x to the 4. Since this is even and this is even, you don't have to use absolute value. X to the 2n over n plus, you cannot read that at all. Okay, n's cancel, which leaves you with 2 on the outside, but 1 on the inside. Since this is 2, we don't worry about absolute value. X to the 6n over n, y to the n over n. Cancel, 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 cancel 1. 6 stays good. Absolute value of y goes to absolute value of y because 1 is odd. Okay, so I just separated everything. The n's cancel here, the n's cancel here, but the n's don't cancel on that 1. X squared is good because it's even. Y squared is good because it's even. But then I have that 1y left over, so it has to go back in the box. X plus 7 to the n over n, which is 1. Since it's 1, and since it's even, it has to go into absolute value signs. X plus 1 to the n over n plus 1 over n, which is 1. Back it up, back it up. Okay. So because this is 1, it's going to go in absolute value. But because this is 1, it stays on the inside also. Same, x plus 1 to the 3 because of that one. And then x plus 1 inside because of that one.